Hi guys, welcome to my channel. In this video we are going to analyze the questions about the structure analysis. The question will be analyzed due to the slab deflection method. We have a beam, we have two supports, and now let's try to solve the question. And first I'm going to specify the fixed end moment. Fixed end moment is for AB. Fixed end moment for AB will be equal to W L squared over 12. So that means that I'm going to take right 0.2 as the force because I'm going to divide it 100 and I'm going to convert it to kip. And for L is 30 feet and over 12, and it will be 15. From A to B it will be minus 15. Minus 15 kips to feet. Okay, so yeah, that will be squared. I forgot it, sorry. And now let's write the equations. That will be for moment AB. For moment AB, 2EI over 30, it's the length of the beam from A to B. So 2 theta A plus theta B minus 3 delta over L. And of course, we have a minus 15 as the fixed end moment, because you know that it is here, for the fixed end moment table, it's here negative, here is here positive. So for moment BA, that will be also 2EI over 30 times 2 theta B, yes, and plus theta A minus 3 delta over L, and of course plus 15. Now you can see it's a fixed, the first support, so we don't need to calculate the theta A, and we don't have any settlement, so there is no need to try to calculate the delta. And also, you know that the moment at B has to be equal to 0, right? And we have a force, it acting at the point C. And this is equal to the moment at B, from the B to A. So it's going to be like that. The moment BA will be equal to 2.4 kip times 10. It's going to be 24, okay? It's going to be 24. This is going to be BA because you know that this is a roller and there is no any for example there is no any moment here, so we are going to be exerted, yeah, it's going to be created by this force. Okay, so now if it is like that, let's write the equation here. 4EI theta B over 30 plus 15 equal to 24, and from this theta B will be equal to 67.5 or EI. Now you know EI is also always is constant. If it's given, you are gonna write it and make your calculation. Yeah, there will no any change. Okay. So let's continue, and now let's define the shear forces. For the shear forces, I'm going to use here. Now I have something like that as my beam, and this is for roller, this is for fixed, this is A, this is B, and this is 2.4 kip as the force. And when I convert the distributed load to the point load, it's going to be 6. Okay, and let's calculate it. As I have a moment at this direction 10.5. I have a VA and I have a VB, right? So total moment at A is equal to 0. I have to show the way or the direction, so that will be 10.5, okay, minus 6 times 15. I'm taking the moment respect to A, and plus VB times 30 and minus 2.4 times 40 equal to 0. And from this equation, I'm going to obtain VB as equal to 5.85. And from the total Fy is equal to 0, I'm going to write here 6 plus 2.5 minus 5.85 and minus VA, right? Yes. And VA will be equal to 2.55 kips. Sorry. And now let's draw the shear diagram and the moment diagram. What I told you from the previous videos, if you first draw the shear diagram, it's going to be easier to obtain the moment diagram. So, for example, this is B, and this is A, okay, and this is our force. It acts. Sorry, I'm not going to show the force here. Sorry, yeah. Now let's draw the shear diagram. Now I have what I have, 255, right? 255. I will goes up. For example, this is 255. And you know that I have a distributed load, and it will decrease my force as the 6. So when I subtract from the 6, 2.5, for example, this will come to here, and it will be equal to 3.45. Okay, 3.45. And for now, you know, at B, I have a force 5.85. So I'm going to raise up. As 5.85, and it will start with 2.4, and I have no any force until the point C. So I will continue with the 2.4, and I will be closed by the force that acts at C. And now you can see this is our shear diagram. And now let's draw also the moment diagram. I'm going to draw it also here. And I guess this is going to be the same point. And if you draw like that, it will be better, because you won't confuse then which point, which was that. So ABC, and I have a moment here as 10.5. I will go down 10.5. This is, for example, 10.5, and I will raise up at this amount of area. How I'm going to find this amount? I'm going to write it as x and write it minus 30 minus x. Okay, when I write here from the geometry, I guess you know that, everyone knows because you're an engineer, and it's going to be 2.55 over 3.45, and x will be equal to 12.75. okay. So I'm going to take the area of this. Now I have 10.5. Sorry, I'm going to write it a little clearer. Yeah, oh, it got worse. Sorry. 10.5. I will goes up with the amount of this area I told you, and I will goes up, and I will reach at 5.7. And then I will goes down at this amount of area. When I goes down, I will reach at 24.05. And yeah, we can see I'm going to again raise up at this amount of area, this 2.4, and this is 10, it will be 24, and it will be 24 and closed. Now you can see I draw the shear and the moment diagram also, and we solve the question. If anything you cannot catch, of course you can text and comment. I'm going to check your comments, and I'm going to make it better. So thank you for watching me. If you like these videos, please subscribe and share with your friends, and comment also. Maybe you can give me a like. I will be appreciated to you. Thank you so much. See you later in the next video.